Hello everyone. In this video, we will solve questions of activity 11.4. Use the below information for question number 1, 2, 3, 4 and 5 only. Consider a string of length 4, a sequence of 4 bits where each bit can be either 0 or 1. Suppose you want to transmit 4 bits wirelessly via transmission channel. The channel is noisy, that is, there is a possibility of error. Assume that the changing a bit at the ith place is independent from the changing the bit at the jth place. So I is not equal to j here. The probability of one bit getting changed is given to be 0.1. Let the random variable x denote the number of bits that changed. So our question number 1 is x is following binomial n comma p. So find the value of n. So here we can see that random variable x is representing the number of bits that changed. Okay, and here we are we want to transmit 4 bits. Okay, so x will be taking the values 0 or 1 or 2 or 3 or 4. Okay, so maximum we can transmit 4 bits here. String of length 4 is here. Okay, so x will be taking value either 0 or 1 or 2 or 3 or 4, and we know that if x is following binomial n comma p distribution, then the range of the x is 0, 1, 2 and it goes up to n. So the maximum value that x can take will be n. So here in the given question, the maximum value that x is taking is 4. So value of n will be equal to 4 here. Question number 2. X is following binomial n comma p, then find the value of p. So in the given question, we can see that x is following the number of bits that is changed, okay, and the probability of success will be the probability of changing the bit, okay, and here probability of one bit getting changed is given to be 0.1, hence the probability of success, which is p, it should be equal to 0.1. Okay, so here the value of p will be equal to 0.1. Question number 3. Choose the correct probability distribution of x from the following. More than one options can be correct. So here we know that in the statement we can see that here x is following binomial distribution with parameter n is equal to 4 and p is 0.1 that we have already calculated. Okay, so here x is following binomial with parameter n is equal to 4 and p is equal to 0.1, and we know that the probability mass function of binomial distribution is ncx p to the power x 1 minus p to the power n minus x. So here n is 4, so cx, and p is 0.1, so to the power x, and 1 minus p will be 1 minus 0.1, which is equal to 0.9. So 0.9 to the power 4 minus x. So here we can see that option number A will be correct. It is same. And we know that 4cx will be equal to 4c 4 minus x. So option number D will also be correct. Okay. Here we have written 4c 4 minus x and rest is same. So option number A and D are correct. Question number 4. What is the probability that the translated message is wrong? Assuming a message is wrong when there is at least one bit error. So we know that one bit error is same as one bit changed. So random variable x is the number of bit changed here. We can see that x is representing the number of bit changed. Okay. So number of here it is given that message is wrong when there is at least one bit error, which means x should be greater than or equal to 1. Okay. So the required probability, which is that the translated message is wrong, it is given as when there is at least one bit error, which means we have to find the probability that x is greater than or equal to 1. Okay, that we can write it as 1 minus probability x is less than 1, right? And probability x is less than 1, which means x is equal to 0. And here we know that x is following binomial distribution with parameter n is equal to 4 and p is equal to 0.1. So by using the PMF, we can find out this probability. So it is 4C0, 0.1 to the power 0 and 0.9 to the power 4. Okay. 1 minus 0.9 to the power 4. Hence, it is equal to 0.3439. Question number 5. An error can be recovered if the number of faulty bits is less than or equal to 1, which means number of faulty bits is less than or equal to 1, which means x should be less than or equal to 1, right? Now, if we send a string, find the probability that the string is either correct or can be recovered. So we have to find the probability that the string is either correct or can be recovered. So suppose this is our required probability. So it should be equal to probability that x is either correct, which means x should be equal to 0. Okay, and it can be recovered. So when it can be recovered, when x is less than or equal to 1, right? When x is less than or equal to 1, then it can be recovered, and when x is equal to 0, which means it is correct. So we have to find the probability that x is less than or equal to 1, which is equal to probability that x is equal to 0 plus probability x is equal to 1. Okay, so here both the things that either it is correct or can be recovered, both things are included here, right? Now, by using the PMF of binomial distribution, we can find the probability at x equal to 0 and probability at x equal to 1, which is equal to 4c0, 0.1 to the power 0 and 0.9 to the power 4 plus 4c1, 0.1 to the power 1 and 0.9 to the power 3. Okay, so it will be equal to 0.6561 plus 4 into 0.1 into 0.729. So which is equal to, hence our required probability will be 0.9477. Okay,